This section is called calorimetry, and you did this in high school using a styrofoam cup. Now, calorimetry is a technique where we monitor a temperature change, and with that temperature change, we're able to monitor enthalpy, the state function. We do that by calculating the Q. I broke this into two parts because working the problems is very laborious, and I also typed in a lot of the numbers so that I could talk my way through the problem. So what we have to start with are two terms that we have to learn. One of them is called heat capacity, and it is the energy in joules required to raise the temperature of an object by a degree centigrade. The second term is called specific heat, and that is still the amount of energy, still 1 degree centigrade, but what we do now is we have a mass component. And that's the one we tend to work with most. The table sitting below is cut out of your textbook, and students often have a very hard time interpreting it. So I said, let's try a contrast. Let's pick the temperature 100 degrees centigrade, or if it's your oven, well, let's pick 212 Fahrenheit. Let's contrast water versus air. What happens if I put my hand into boiling water at 100 C? I will get severe burns. That's because water has the ability to hold many joules of heat. What if I put my hand into an oven? Now, air is 78% nitrogen, and if you look at the chart, it has a specific heat of only 1 joule per gram degree centigrade. 4 times less than water. So while I may feel a bit of discomfort, I'm definitely not going to feel a burn, okay? So I've got one of the homework problems worked on the next slide. Not that I don't trust you, but you'll understand why when we do it together. So we're going to be determining that enthalpy, that delta H. We're really determining it using QP, but we tend to just say Q because we assume there's constant pressure for our reactions. And you've probably seen this equation before. Q is equal to the specific heat times the grams of the substance times the delta T, where the delta T is always the final minus the initial temperature. So this was an office hour favorite, which is why I had to bring it up. Let's say we have heated up 2 objects. We then place them into 1,000 grams of water. We have object A we're going to place in object B. And again, it's 1,000 grams of water. What does A do when we place it into water? It increases the temperature by 3.5 degrees centigrade. What does B do when we place it into water? It increases the temperature by 2.6 degrees centigrade. So the question asks, which has the larger heat capacity? Is it A or is it B? Well, A increased the temperature more, so it has the higher heat capacity. We've had many discussions office hours about this, and it leads to even more discussions, but I wanted to kick things off. Part B says, what can you say about the specific heat? Well, specific heat needs a mass term. We are not given mass, and therefore we can't say anything. We can say nothing. So that's why you need to work on the word problems, because they have a lot of interesting twists and turns, okay? Let's do some calculations. The first one we want to do is calculate the amount of heat, and we use, for an example, the heat of water. So the problem says we have 1 kilogram of water, and the temperature increased, that is my initial, to 22.7, which is my final. How much heat was absorbed? You will always be given the specific heat, although after working problems, no one's going to need to give it to you. So what I did here is I said, write down what you know. You have 1 kilogram, you have an initial temperature and a final temperature. Look back at the equation, and I hate to say plug and chug, but this is kind of where it comes into play. We've got our specific heat of 4.184. Since we have grams as our constant, we need to put our mass in grams. And we have our temperature difference, 26.1 minus 22.4. That is a difference of 4.1 4.51 degrees centigrade. So when I do my math, I come up with 18852 joules, and normally answers are asked in terms of kilojoules. 18.9 kilojoules is our answer. Now, this could be a midterm problem. If it's an ACS exam, this is probably about as far as they go. I do not know what will be on your common exam, but I do know your life will extend past Ohio State. So I want to do a couple more problems. One of them is, how do you calculate a specific heat? You're always given it for water, but sometimes you are asked to find out what it could be. So let's draw a little picture based on the words that are in this problem. I have some water, and it says that I have 162 grams of water, and it is sitting at 22.4 degrees centigrade. It says I am heating a block of iron. There's my block of iron. It weighs 75 grams, and it is sitting at 99.8 degrees centigrade. Both of these are the initial temperatures of the two items. When we come to equilibrium, I would say our final temperature is defined as 26.1 degrees centigrade. So there's the word problem, there's a picture. Take a pause, make sure you understand where the problem is starting. So we have two different calculations we do. One of them is finding how much heat was gained by the water. We have our specific heat of water, we have our mass of water, and we have the temperature change, which turns out to be 3.7 degrees centigrade. When I crunch my numbers through, I get 2508, a positive number, joules for the heat of the water. Now, the heat gained by the water is the heat that is lost by the iron. That means that in order to use this, we need to say this refers to water, minus 2508 joules refers to the iron. That brings us to the second set of equations that we're going to use, where we're looking for the specific heat of iron, and we have the other variables provided. So here is my Q of iron. I've just noted it up here. Here we're looking for that specific heat. We have 75 grams, and we have a much larger temperature change, 73.7 degrees centigrade. When we work on those numbers, and what I just did is I rearranged it. We have all kinds of students in this class, and I want to make sure I don't leave anyone behind. So all I did was rearrange the algebraic expression, and I come up with 0.45 joules per gram degree centigrade. That would be my specific heat for the iron. So notice the units. I've got joules on the top. I've got grams and centigrade on the bottom. Notice that I have a negative sign on the top and a negative sign on the bottom because the specific heat will always be a positive number. Now there are two more slides on this PowerPoint, and I call this one part one. For me to talk my way through this, I just want to do it on another slide, and I have two more examples to share with you. So before you go watch the next video, take a look at this slide, take a look at the calculation slide. It could make a huge difference in your understanding. So from this slide set, what we have is the topic of calorimetry. We have talked about heat content and specific heat, heat capacity and specific heat. We've shown how to do a single Q calculation. We've shown how to do a specific heat calculation. All are very important for you to master. And if you have questions, please ask them.